This is a tutorial on double displacement, which is one of the 6 chemical reactions. The things to remember are, there are 3 types, that both reactants will be aqueous, and that you need the solubility chart to predict what the states of the products will be. So here's a generic example. AB plus CD produces AD plus CB. So A and B will no longer be together, and A will come together with D, and the same for C. It will no longer be with D and come together with B. To remember this, the inner ions will come together and the outer ions will come together, which will produce AD plus CB. Also remember that these are the metals and they will always come first. So the first type is the formation of a precipitate. So here's an example. Lead nitrate, aqueous, plus 2 potassium iodide, aqueous, will produce lead 2 iodide, solid, plus 2 potassium nitrate, aqueous. Now, this is the same as the generic example. The lead and the iodide will come together, and the nitrate and the potassium will come together to produce lead iodide 2 plus 2 potassium nitrate. Also remember a balanced chemical equation, and also remember that in order to find what the states are for these, you need to look in the solubility guidelines, which is right here on page 124 in our workbook. So what you would have to do is you would have to find lead at the side, and since it's lead 2, you would look at lead 2. Then you would have to find iodide, come together to see where they meet, and as you see, they meet right here, which says I, which is also equal to saying insoluble, which is also equal to saying it's solid. But for potassium and nitrate, potassium and nitrate come together to say S, which means soluble, which means it's aqueous. And this applies to all the double displacement reactions. The second type is the production of a gas. So here, but this one is a little different because it's a 2-step process. So step 1 is the regular double displacement reaction, while step 2 is when one product decomposes to make a gas. So we'll do step 1 first. In this case, it's sodium carbonate, aqueous, plus 2 HCl, aqueous, which will produce 2 sodium chloride, aqueous, plus carbonic acid, I believe. Okay, so as you can see, we did the same step here where sodium went with the outer one, which is chloride, and carbonate came together with hydrogen, which produced that. Now, that was the first step. So we'll erase this half. Since it says that one product decomposes to make a gas, these are the products. The ones on the right-hand side are the products. So you look at them and analyze them, and you determine which one will decompose, and in this case, it will be H2CO3. And this will produce H2O, which is water, as you know, plus CO2 gas. So as you can see, one product decomposed like decomposition, and it produced water and CO2 gas. The third type, and the last one, is the formation of water in a neutralization reaction. So, in other words, an acid plus a base will produce water and a salt. So, for example, an acid, which would be nitric acid, plus a base, which is sodium hydroxide, produced water and a salt, sodium nitrate. Again, the same displacement, but it is the formation of water in a neutralization reaction because a base would have neutralized the acid. So I'll give you some questions that you can do to practice. So you can use these to figure out the displacement, and also remember to look at the solubility chart for the guidelines, and to remember my rule, or the rule, about the outside ions coming together and the inside ions coming together. So you can pause the video and watch and try them. Okay. And another thing to remember, just to finish off, is that if the two products are aqueous, then there is no reaction, because all ions would have dissolved, which means that when you have a question like that on a test, you would just write the arrow and just write N.R for short. So there's more practice in the workbook. So yeah, thanks for watching.